All right. Good afternoon, everyone. Hey, how was lunch? Yeah? Conference food good? We all love conference food. Okay, so traditionally, I should say Selamat Tengah Hari. So I'm from Malaysia. I'm Raymond Chow. I'm from Infront Consulting Group. I work out of the Singapore office. I'm actually based in Malaysia, so I live in Malaysia. It was only a 28-hour flight for me to get here. Yeah. So if I fall asleep halfway during the presentation, please forgive me. So primarily what I do in my day job is I do consulting on systems management, virtualization. I work primarily on System Center Operations Manager. And I have with me the one and only King, the King. Alec, you want to quickly introduce yourself?
Yes, sure, thanks. Hi, everyone. Welcome from me as well. Thanks for coming. My name is Alec King. I work for Veeam Software, where I am the owner of the Veeam Management Pack for VMware. I won't be doing a sales pitch for that today. If you'd like a sales pitch, I absolutely invite you to our booth, number 1001, where you can get a great demo of that MP. What I want to do today is share some of the experiences we found when building that, some of the best practice stuff around monitoring a VMware environment, in my case, and let you guys take that away and make the informed decision about what the best solution is for you.
Thanks, Alec. Okay, so when we came up with this topic, we wanted to address a couple of things. So in my job, I speak to a lot of customers, and everyone's going into the basis of virtualization, right? So how many of you guys are already in a virtualized environment today? Just show of hands. Wow, everyone. Everyone not? Anyone not? Planning to go there? Are you planning to?
I love the holdout guy there. He's great.
Yeah? Okay, so how many of you are on Hyper-V? How many on VMware? More hands than Hyper-V? I wonder why. Anyone on anything else? Okay. Zen? Zen Server? Okay. So unfortunately, I won't be covering Zen Server today. Right? You don't have to leave the room. You can stay on. So I wanted to basically kind of just lay out some of the metrics and practices for virtualization monitoring. Because a lot of the times when I go and talk to my customers, and a lot of the times when we go into virtualization, everyone's so excited, right? Oh, I want to go on virtualization, right? Virtualization gives me flexibility. Virtualization saves me money. Virtualization does a lot of things for me. It helps me mow my lawn, I hope, right? But how do we actually measure like performance, right? How many of you guys know this, the Jawbone Up band? Anyone heard of it before? So there's this little band I'm wearing on my wrist. So it helps me keep track of how long I sleep every day, how many steps I walk every day, and when I sleep, how much of those time am I on deep sleep and light sleep. So when I actually looked at it, I was really excited. I said, oh, cool. I can actually know how long I sleep every day. I can see a nice little bar that shows me how much deep sleep and light sleep.
But have you integrated those metrics into System Center?
No, I have not.
We'll get on that, man.
Right? So I was really excited, just like how any one of us would be excited to go on virtualization, right? But then again, when I look at it and I look at those graphs, then I ask myself, right, what am I actually looking at? How is knowing how many hours I sleep a day going to benefit me? Right? So in that context, I wanted to share this session and kind of just go through some of those metrics that we feel that is important. And there's a lot of metrics that we can use, right, for virtualization monitoring. So I just wanted to bring up some of the key ones. And I wanted to make sure this was cross-platform. So I'm going to talk about Hyper-V, and Alec there will talk about VMware, which he's good at. All right, so the objective of this session is to kind of go through some of those metrics and also to take a look at some of the tools that we use on a day-to-day basis. How many of you use monitoring tools? Okay, how many of you use Operations Manager? Okay, good. Are you guys monitoring your virtualization platforms with Operations Manager? What do you use, sir, for the Veeam Pack? What about you guys on Hyper-V? What do you guys use for monitoring? Anyone? Or no one uses COM to monitor Hyper-V?
We use it, but it's
Okay. Okay. Right. That's, yeah, no, I totally understand. Right?
Firm but fair.
That's very good feedback. And I'm going to show you some of the stuff that I just built on the fly, and I'm going to post it up, and you guys can have it. Right? Okay, so these are some of the questions that a lot of the customers kind of want to answer. Right? So kind of like why CPU resources are causing performance issues. Right? So there's always the case where we get a call from a user. So we get a famous call saying, hey, the application is slow. Right? Something's wrong. So with that information, can we immediately troubleshoot and say, okay, it's CPU? We can't, right? It would be so useful if we get that kind of call from users, right? Users calling us and say, hey, the application is slow. You might want to check the network port on switch number 3, port number 7. I think there's some network latency over there. That would be like so ideal, right? So no. How much are we wasting on storage? When we embarked on virtualization, the biggest component or the biggest piece is storage, right? When is it ever enough? Right? Virtualization makes things flexible. Virtualization makes it so easy to create virtual machines. So then comes the story of storage. Are we wasting storage? Can we identify memory issues before it escalates? Right? So let's not run out of memory. When that doesn't always pan out well. And is this throughput problems creating VM problems? So these are some of the questions that on regularly that our customers actually ask. Now, so what do we actually monitor? Now, if I were to break it down into 4 quadrants, availability is the first one, right? So simple stuff, we just need to know whether it's running or not running, right? And second is configuration, performance, and capacity. So when we talk about availability on a virtualization platform or even Hyper-V, these are some of the key metrics. So things like status monitor, we want to make sure that it's up. We want to make sure that the processes are running, the services are running. The status of our cluster, it's good to know, right? Whether the cluster is up or not. Whether there's any migration issues. Right? So in Hyper-V or even in VMware, we have live migration or vMotion. Was there any problem when a virtual machine migrated over to another host? Right? Connectivity is something that we monitor on availability. And also any hardware issues, power supply, temperature, fan, and so on. Right? Now, this session, I wanted to concentrate more on the performance part. Because availability, it's quite straightforward. Most tools out there will actually show you availability. If you don't have a tool, you can always just stand in front of the server and just look at it. It will tell you with the lights. So monitoring configuration, there are some best practice analyzers out there. So for those of you who are familiar with Windows Server 2008 R2, so we had a best practice analyzer that you could install and load. But what about 2012? How many of you are on Hyper-V 2012? Okay. Did you guys load in a BPA for 2012? No? Well, you don't actually have to because BPA is built into Windows Server 2012. All right? So if you open Server Manager, BPA is built in there. You just have to turn it on. Right? So you don't actually have to go look for a BPA for Windows Server 2012. So that's a tip for you. Now, in environments that we have seen that customers are using Hyper-V and VMware, from a central monitoring perspective, there is a tool called System Center Virtual Machine Manager. Right? So Virtual Machine Manager gives you kind of that central look to both environments, and it connects to Virtual Center to actually see the VMware portion as well. Right? So that's one way to kind of look at configuration from both ends. Okay, just wanted to share those with you before we go into performance. Okay, so let's go straight into the performance part of virtualization. So I'm going to talk about Hyper-V first. So based on the 4 areas that we try to look at capacity or performance, I've highlighted some of the key metrics, and let's go down to it one by one. Right? I wanted to go a little bit deeper in today's session. So let's talk about CPU first. Okay? Now, when we want to measure performance of our virtualization host, what do we actually monitor? Okay? Now, in the past, when it was all physical, it was easy, right? So when we hit an open performance counter, we basically just choose processor and percentage runtime. total runtime, right? And then we'll just look at it. Or even easier, this is what we used to do, right? So we used to go here, boom, task manager. Right? That's what we used to do. Hit task manager and just look at the CPU. Let me shift the CPU. Yeah? So looking at task manager, it's all fine and dandy. Our utilization is at 3%. So my Hyper-V host is running 3%. It's all good. I have a lot of CPU power. Is this correct? No, it is not. Okay? So for those of you who are new to virtualization, this is a quick tip for you. Looking at task manager isn't actually looking at the correct information. Okay? So what do you look at? So, and why is it that it's a wrong information? Let me just quickly share this with you. Okay? So, if you look at how Hyper-V works, and this is for Hyper-V, all right? And Alec will share with you on VMware a little bit later. So if you look at how Hyper-V is being installed, the minute you install Windows Server 2012 and you enable Hyper-V, it lifts up the operating system and it basically lays down the hypervisor, Windows hypervisor at the bottom. Right? And that operating system that you installed first becomes like a virtual machine. So it puts it in a parent partition. So when you're actually measuring percentage processor time, you're only actually looking at the metrics for that guy, just the parent partition. So you can be loading virtual machines in there, and it will still show 3%. Right? So that's very important to know. So what is the metrics do we look at to look at the whole stack? Right? There is this counter here called, I'm not sure if you can see it from the back, Hyper-V Hypervisor Logical Processor. Okay? So you want to look at this metric, and total, the instance is total, percentage total runtime. And this is performance monitor, right? So we all know performance monitor. And if I do that, you can see that that is actually the total amount of CPU usage for the whole host. So that is the first counter that I will look at. Right? So that counter over there. Okay. By the way, I'm presenting from my Surface RT, which I think is pretty cool. How many of you actually bought the Surface? How many of you queued for 3 hours to get it? You know what's a good metrics? I was online yesterday. I was on eBay. And on Sunday...
Were you really?
Yeah. On Sunday, there was 200 posts on eBay selling Surface RT. Yesterday, there were 2,300 posts selling Surface RT. Interesting, right?
Just flip it.
Oh, so funny. Okay, let's go back. All right, so that's one of the metrics that I would see from the host level. Now, if your host CPU is peaking, right, then the next question that I would normally ask is, which virtual machine is causing this peak? If I'm hosting like 10 or 12 virtual machines on that host, I want to know who's the culprit, right? So what I would normally run is that next counter there, which is hypervisor virtual processor. Okay, so virtual processor, percentage guest runtime. So if you go to performance monitor, and performance monitor, you know, is a free tool, right? So I'm not even showing you any paid tools yet. So these are already available in any Windows server. So all you got to do is just go up to just look for the counter that says, where are you? Hypervisor virtual processor. Okay, and on percentage guest runtime, you will see a list of all your virtual machines and the relevant virtual CPUs. Okay, so all you got to do is just load that in and slowly just go through those virtual machines to see which one is the one that's peaking. Okay, so that will help you immediately tell where you may have to shift certain virtual machine loads to another server or so on. Okay? All right. So that's a couple of tips there. Since we're on a talking point on CPU, so I had a question. I did this presentation 2 weeks ago, and I had this question from the audience. How many virtual CPUs can we actually run in an optimal scenario based on the number of physical processors on the host? Anyone knows? Or maybe just has an idea? Sorry? So if let's say I had a physical CPU with 6 cores, one CPU with 6 cores, how many virtual CPUs can I assign to any virtual machine? 6? Any more than that? 8 to 1 ratio? Have anyone heard of a 12 to 1 ratio? Yeah? Exactly, right? So if you know that I'm just going to quickly show this to you, right? So in any virtual machine, let me just choose one which is turned off. Right? In any virtual machine, right, you can basically assign, right? And you know in 2012, this number here goes up to 64, right? So, but what happens when you assign 64 on every single machine? Right? So the 8 to 1 ratio or the 12 to 1 ratio are basically just guidelines. Right? So if you look at any blog post or any articles that says 8 to 1 or 12 to 1, these are guidelines for optimal performance. Right? 12 to 1 talks about VDI. So if you're running Windows 7 virtual machines, then you could probably base it on a 12 to 1. If you're running server workloads, 8 to 1. Now, the best optimum situation obviously is a 1 to 1, right? The best, right? One virtual CPU to one core, right? But obviously that isn't good for the cost portion of the situation. So, but just for your knowledge, every virtual CPU is assigned to a core, and then it starts cycling, right? So the more virtual CPUs you assign, then it starts cycling among the different cores. Okay? So that is kind of how we evaluate the situation when we're talking about assignment and looking at virtual CPUs. Okay. So what we normally do is look at the total logical processor percentage total runtime, look at your guest runtime, right? Compare the two, look at it, and if it's roughly less than 60% consumption, then it's very healthy, right? Obviously, if it goes above 90%, means you only have like a 10% gap before CPU utilization is overworked, right? So that's how we measure performance there. Okay, let's talk about memory now. So from a memory perspective, it's very straightforward. We just need to know if there is enough memory left, right? So the counter is memory, the same one for physical, and basically just available megabytes. 50% of free memory is good and healthy. Anything which is 25% and below means that you only have that much buffer left in terms of memory. Okay? Be careful when you're using Hyper-V clusters and you're doing failovers. So make sure you have enough of room for every other machine from the other host to fail over to you. So that is how we measure that available megabytes memory. Okay? Now, one of the other metrics for memory is pages per second. So this relates to paging. So we all know what paging is, right? So the minute we see that memory starts to offload back to disk, then we know that there's just too much of stuff running in memory. Okay? So if the memory counter for memory pages per second it goes like above 1,000, this is a cause of concern, right? Means you're just running too much of stuff in memory. this is a good justification to add more memory. So if you look at this counter and it's above 1,000, then this is a justification that you can go and buy more RAM. This is one off, okay? Other than obviously needing more RAM to host more virtual machines, right? Okay, let's talk about network. Now, how do we test for network performance? The first thing I would do is do a ping. How many of you think ping is uncool? Well, I was giving this talk again in about a month ago in Singapore, and someone says to me, ping is not cool. Everyone knows ping. Teach me something else. Right? Well, then I came up with path ping. Right? Is that a bit more cool? So path ping, for those of you who have never tried it out, what path ping does is path ping sends 100 packets out and calculates how many come back. So this will tell you whether you are suffering from some packet loss. So if 100 comes back, 100 goes out, 100 comes back, good. 100 goes out, 80 comes back, means you might have some noise on your network. Okay? You might want to look at it. I would perform a quick file transfer copy just to see how long it takes. Right? A 100 meg file, normally on a gigabit network, normally takes about 3 to 5 seconds. So anything more than that, right, you know there's something else running on the network which is causing that kind of latency. Okay? Now, from a performance counter perspective, I would look at the network interface bytes total per second. Right? Basically, this will give me the bytes total that is going out and in. What we normally do is we'll take this metric, we times it by 8 to get bits, and then times it by 100 to get the percentage. Right? Sorry, compare it with your network. Like if it's a gigabit network, it's 1,000 gigabit, then convert that to percentage. Okay? So if it's obviously below 40%, means it's below 40% consumed, means you're good. So if it's above 65%, means your network interface is 65% consumed. Means there's as much as load that's happening on the network interface. Now, how do you look at bottlenecks? So bottlenecks, we look at output queue length. Queue length, just like you guys were queuing for the Surface, right? The higher the number is, you know, the longer that you're going to be waiting for that $99 deal, right? So we want to make sure that there's no one in front of us, right? Zero queue length. So if you're always on zero queue length, means that your network is healthy and no packets are queuing up to get onto the network, right? So these are some metrics that you can set. Now, two kind of practices or pointers that I've noticed in customer environments. Number one is if you have MTU settings and you set out of the default for MTU settings, make sure that every network interface that communicates with one another has the same maximum transmission unit settings. Okay? Having different MTU settings means that you will have to recalculate, so there will be some performance degradation from it. Yes? Okay, question here is, do we see a lot of performance increase by using jumbo frames? The answer is, we do see performance increase, not significantly, but it really depends on also what type of load or I/O that you're looking at. Normally, we would turn it on if the switch allows it, the host allows it. For that additional performance increase, it actually justifies turning it on. Is there a reason why you would?
Yeah, iSCSI, I think you'd see a jump with jumbo frames.
Generally speaking, the consensus of my company, which I debate, is they tend to think it doesn't do enough good and it can cause problems, so don't turn it on.
What type of problems did they think it would cause?
They'll find some latency problems down the road and even when you call on vendors, the first thing they do, turn on jumbo frames. See, that fixes the problem. Once it gets turned out, it never gets turned back on.
Wow, okay. I'll be interested to have a conversation with you later. Yeah. I disagree, so That's my take. Okay. The second thing that I wanted to point out is, you know that there are some, a lot of adapters are the combination adapters. So they're the 10/100/gigabit or the gigabit/10 gig adapters. So what we've actually noticed is also that the auto detect and auto switching doesn't really auto detect and auto switch. So sometimes it's a gigabit network or a 10 gig connection. Somehow it auto detects it as a gigabit. So normal practice, what I would do is I would just set it to whatever that I want it to be. So if I want it to be a 10 gig to a 10 gig, I will just set it at 10 gig to a 10 gig. Okay, so this kind of just eliminates the possibility of it ever detects the wrong bandwidth. Okay, so that's network. Now this latency, some of the counters that I use is logical disk, average seconds read and write. So this basically, we just want to know how fast the data is being read and written. Anything below 15 milliseconds is healthy. Okay, anything above 26 milliseconds, it's a cause for concern. Now, this metrics is based on a 7,200 RPM disk. So if you're running 10,000 or 15,000, this one will come down even further. Okay, so this one will be faster. This is based on poor performance. All right. So as I was mentioning earlier, a lot of these tools, or a lot of these metrics, and these are some of the very basic and key metrics that I would actually look at. Then we go into some of the others. Like, for example, let me go back to memory. How many of you guys use dynamic memory? Okay. How do you measure whether dynamic memory is performing well or not? So the counter that we normally use is, there's a counter called Hyper-V Dynamic Memory Average Pressure. Okay, and I'll show that to you in a little while on SCOM. All right? I wanted to bring this up, AV exclusions. I think we all, in virtualization practices, we know that we have to make sure that we exclude AV, antivirus scanning on the virtual disk, right? We actually came across a little issue a couple of weeks ago. One particular antivirus company, I won't mention who yet, but we were running Windows Server 2012, Hyper-V, and we did some exclusion on antivirus, and everything was based on best practice. We excluded the virtual disk and so on, the folders, and the VMs were actually crashing. The VM still was crashing. And we tried to find out what was going on, and it was solved the minute we turned off that antivirus service. So for some reason, some antivirus today still doesn't play well with Windows Server 2012 Service Pack 1. Okay, so that is just something that I just wanted to share with you guys in case you face that issue. It may be because of that. All right? Okay, now we've looked at performance monitor, we've looked at some of the key metrics. We know that performance monitor is run on every single server. All right? So if we had 2 servers, okay, that's fine. What if we had 73 servers running performance monitor on every single server and looking at the metrics? May not be something I want to do. So a centralized monitoring tool is helpful just so that it helps you to collect all these data for central reporting. It doesn't have to be System Center, but I personally use System Center and I preach about System Center. Okay, so System Center gives you that kind of view. So let me just quickly show you what I have on my Operations Manager environment. Okay. Now, so what I normally do and I share with a couple of our customers is all those metrics that we talked about, it's actually very easy to get it centrally monitored on System Center Operations Manager. Okay? Now, I've created a small management pack, and this is actually very easy to create. Now, what I'm going to do is I'm going to release this management pack on the blog, and you guys can have it. This particular one is built without a single piece of code. All right, so this is built just by creating monitors and rules in System Center Operations Manager and just creating the views and dashboards. So it's really easy to create. So it's all about basically just going in there and looking at those metrics earlier. So just hit that. So this is one on CPU performance. This is looking at my host. Remember the percentage processor time. So I have that in there, and I have the total runtime there. So can I actually see the comparison between total runtime and the processor runtime at the bottom, the flat line you can see over there. Okay? So from a central monitoring console, I can see both my Hyper-V host up here. So instead of looking at two performance monitor consoles. So how I basically create these views is very simple. I'm just going to give you a quick tutorial. So in case you've never done this, it's all under authoring. All you got to do is, what I do is I create a group. So if you don't use the default groups, you can just create a new group. And when you create the new group, you basically just define the servers that you want as part of the group. It can be an explicit member, or you can just create a dynamic group that just says machines, which is Hyper-V host. Okay? So I've created a group which is called Hyper-V computers. And I basically target some rules of collection based on that. Okay? So the next thing I normally go and do is I will go and create a rule. Now, if you are wondering why I'm doing this, because like this kind gentleman stated earlier, the current management pack, it's not really usable. So we normally do this ourselves. So you can actually very simply just go ahead and create a rule. I'm just going to quickly show you how to do that. So it's a performance-based rule, and it's a Windows performance. I would select a management pack to put it all in there. So I created one called just Windows Server 2012 Hyper-V Management Pack. You can create a new one by clicking this button here. Go next. Give it a rule name. So if I were to call this maybe Hyper-V Logical Processor. And I would then go ahead and target that rule. So I would target this rule in the group that you created. Okay. So, oops, sorry. This wasn't the group. Windows Server 2012. Okay. And this was the group that I created. Right? So I'm targeting that group, and that group has the members of that two hosts of my Hyper-V host. Now I'll go ahead and click on select, and very simply I'll go and target one of the hosts. One of the hosts is called HYP01. Right? And in there, it will list down all the performance counters. Then just like how you would go to Performance Monitor, just go to the Hyper-V, Hypervisor, Logical Processor, and total percentage, total runtime, and select total from there. Okay? You can select the different cores if you want, but I'm just going to do it on total. Select the interval. You can leave it at 15 minutes. Right? And then just go ahead and create it. Okay? So the minute you create, you have this rule. I'm just going to cancel because I've already done it. And then you basically have this rule, and it'll tell all the SCOM agents to basically start collecting those metrics and put it into the database in Operations Manager. Then the next thing I would do, or in this case, I would go ahead and create a view. And that's very simple. Just create a folder here. Go to New, View, and select Performance View. Give it a name. Just going to call it Logical Processor. And you can actually narrow it down to that group, just to make sure. Okay, so I have the Hyper-V computers. Then I go and say collected by a specific rule, and then I go ahead and choose that particular rule. Right? In this case, the rule that I created is called TechEd Logical Processor Performance. Okay, so the minute you do that, you'll be able to see this view I created here. So I have, so this little management pack here took me basically about 30 minutes to create. So I have some on CPU performance, dynamic memory, VM performance. Right? So at one glance, I can see like how much pressure. So this is what I was talking about. So if you have dynamic memory running and you want to know whether or not the amount of memory demand your virtual machine is asking for and whether or not your dynamic memory is enough, make sure that this counter is below 100%, obviously. If it's above 100%, means that the virtual machines are asking more than what you are assigning as maximum dynamic memory. Okay? So I've also gone ahead and create some dashboards, and these are just basically dashboards that you can actually create in the view. So this, I have no authoring needed. I do not use Visual Studio for this. And very quickly, I can see, based on my Hyper-V, the memory available, the paging status, the counter that we were talking about, and the dynamic memory performance as well. Okay? And this is basically just by going right-click, selecting New, and select Dashboard View. Right? Then for each of those widgets, those 4 widgets there, right, like this one. So I have one over here, CPU performance. Right? So I have 2 here. So all you got to do is just click on Add Widget. And select which of the different templates that you want. Performance widget will show you the graphs. State widget will show you basically your green, yellow, and red lights, and so on. Objects by performance gives you kind of like a listing. And this is objects by performance here. There you go, down here. So I say objects by performance, then I choose the CPU performance, and then I say list down for me top 5. Obviously, I only have 2 hosts, so you only see 2 up there. So I can actually see the metrics on my average value. So which one is actually giving me the highest CPU utilization. So these are some of the dashboards that I find useful in terms of measuring performance of Hyper-V. Okay? So yeah, I'm going to post this up and you guys can have it. I've just got some parts to clean up. Okay. Now enough about me. Let me switch over and hand you to Alec, who's going to talk to you about some cool stuff on VMware. Over to you.
Thank you very much. How does this work now? Nice fade. So yes, hello again, folks. Like I said, no sales pitch today for the VMware MP. How many of you already have the Veeam management pack for VMware? Nice. But what I want to talk about today is some of the lessons we learned and the concepts that you should, I think, keep in mind when you're choosing a monitoring management solution for a VMware environment. The high-level concepts and some low-level metrics as well. And I'll use our management pack to illustrate how we implemented that, but it's information for you to make an informed decision, I hope. So some of the options you have. Do nothing is the first one, really. Use vCenter. I've already got vCenter. I don't need a monitoring tool. Well, vCenter is your administration and your configuration tool, but it's not a monitoring tool. It has some basic alarms in there, but they are not very granular, not very informative, and you'll never get the rich kind of dashboarding and reporting that you get in a proper monitoring tool. So vCenter, the do nothing option doesn't really work for me. An agent in the virtual machine, an agent from your other monitoring framework, System Center, for example. Most of our customers do have agents in the virtual machines as well, but the problem is that agent has tunnel vision. It's great for monitoring the applications and the services, your SQL, your Exchange, Active Directory issues, whatever's going on inside that virtualized OS. Great visibility of that, but it can't see the actual host hardware where it's running. It doesn't understand about vCenter. It's vMotioning it right now. It doesn't see the real storage. It doesn't have that picture into the real environment. It's encapsulated in the VM. That's how it works. And it can't really see outside of that. So by all means, put an agent in your virtual machines for the complete end-to-end picture, but it's not going to give you the virtualization layer. SNMP and syslog, yeah, they are available. There's some SNMP stuff exposed in a VMware environment. But I do view that as kind of legacy. If you really love like juggling lib files and so on, then you might build something out of SNMP. And syslog as well. Syslog is still available. There's even a syslog collection mechanism in the latest versions of vCenter. But syslog, again, a little bit legacy. It's very verbose. Even if you just start a VM, it will generate 50 to 100 separate syslog messages. And it's quite cryptic as well. Even if you try, okay, I'll just capture errors and warnings and criticals, they're very cryptic, the text you get out of syslog. You'd be left, really, to build some kind of parser, some kind of recognition yourself to recognize those messages, understand their impact, what they mean. And building your own solution is a challenge. It's been 5 years now, more than 5 years, I've been building our management pack. So if you want to build your own stuff, you probably better get started soon. The VMware Web Services SDK, the API into Virtual Center. You can also use it direct to a host. That's really the best practice method. VMware built this for this very purpose, to expose your virtual topology, all the metrics you need, the events, everything around your environment is available through that SDK backend. It's secure, it's very scalable, it's very detailed. And that's what VMware recommend. And I think most of the solutions, the plugins, the monitoring tools, and so on that you'll see in the market will use the SDK in the back end. I would say that's your best choice. Understanding the methods and what you want to do, then you have to choose a monitoring tool. And I'll just come straight out and say I think System Center Operations Manager is the best tool, especially if you've got a Windows estate, Windows applications, Exchange, SQL, IIS websites. The Windows OS itself, it's absolutely best of breed for monitoring that stuff. Microsoft write the platform and the apps. Microsoft write the management packs for that. And bring VMware into that picture. I'd say that's the biggest feature of our management pack. We have a whole bunch of features for what we do for VMware monitoring, but I'd say the single biggest feature is the fact we bring it to System Center. Integrate it with your critical business applications and services that you're already monitoring there, and that's how you get end-to-end, app to the metal, that single pane of glass that we're all reaching for. So high-level concepts, what you want to think about. You need a map. You can't find the treasure if you don't have a map. And by that I mean you need to be able to track the many relationships and dependencies in a virtual environment. Which virtual machines are on which hosts, which apps are on which virtual machines are using which storage. You have to have a map of that, or you're troubleshooting in the dark, pretty much. A part of that as well, like take that map further, and you need a product, you need something that gives you good visualization. Again, it's a very large environment, as some of our customers, very large, and very dense as well in those relationships. And having dashboarding and reports that expose what's important in that wealth of data, there's a lot of data down there, that's essential. And having the ability to drill down in context, contextual information, grab your cluster, show the top host, drill into that host, find the top VM, and get to the root cause of the problem, find the hotspots and drill in. Play nice. Virtual machines don't always play nice. They really don't. And there's a lot of resource sharing going on. That's what's great about virtualization. You can pack a whole bunch of servers onto one server now. But guess what? Now they're all contending for CPU, for memory, for a whole bunch of resources that maybe didn't even exist in your traditional server monitoring world. And understanding how that sharing operates, what are the KPIs around that sharing, and even being proactive, having policies about how you deploy and how much you overcommit and overshare those resources is critical. Have a plan. You need features like forecasting, like trending, modeling, what-if scenarios, modeling host failures, trending your resource usage to the future to know if you can fit this new VM project. You've got 2 Exchange VMs to deploy next month. Will they fit on your cluster? To know when you're going to run out of storage space, or even more important, out of the performance. When's your latency going to suddenly climb on the storage? And so you can order more hosts, more memory, more storage. You need this stuff to convince your boss, right, that you really need a new host. So I'll talk about some of the critical metrics that whatever monitoring solution you choose should definitely be watching. And the overcommitment, like I say, it's a great feature of virtualization. You can hand out more CPUs than you actually have. You can hand out more memory than you actually have, but you don't get nothing for nothing, really. And we implemented a range of pressure metrics in our management pack to track this stuff. Overcommitting for CPU pressure, we called it, and it's the number of virtual CPUs per host core. We already discussed it in the Hyper-V world.
Yeah.
If you have a high ratio to that, you can really impact the ESXi CPU scheduler. It's managing that. It's giving all your virtual machines a slice of the real physical CPU. But once that number gets high, then it spends all its time trying to schedule, and none of its CPU is actually given to the VMs to run. It's one reason you can actually see a VM performance drop if you start throwing more CPUs at it. You get what's known as CPU latency. What this VM is waiting to run. There are real-time, if you like, reactive metrics in a couple of slides about that. But watching the CPU pressure, knowing how many powered-on VMs is what we use, and the ratio of powered-on VM virtual CPUs to host cores is important. Maximum of 25 in the vSphere environment. Best practice of 4 to 8. So again, you can be proactive about that. With a metric like that, you can make sure that you stay within your design standards, within your policies for that environment. There are metrics that will light up once you've stepped over that bound, but be proactive and catch it before it happens. Memory pressure is a similar one. Give up more memory than you actually have. That's great. And VMware, the vSphere hypervisor, is very efficient at sharing common pages, transparent page sharing, TPS. All those VMs that are loading Windows Server 2012, for example, they transparently in the background share the same common pages of memory. It's a great feature. And it means you can overcommit memory pretty heavily. But again, before the actual reactive metrics, which I'll mention, kick off, understand how overcommitted you are. Some of our customers don't overcommit at all. They just give out the exact memory to VMs that the host has, and there's no sharing going on. It certainly means they're completely safe, but they're maybe not getting all the benefits of virtualization. I would say push it a little harder, but understand how hard you're pushing it. We have a custom metric in our management pack that factors in the memory you're given to VMs, the overhead memory, which is what the hypervisor needs to actually run the VM. We factor in the page sharing, and we give you that as a percentage to let you know how overcommitted you are. And the final pressure metric is disk pressure. Again, thin provisioned disks, it's great. The virtual machine only takes up the actual disk space it's using. The white space is not deployed to your back-end SAN or whatever. It means you can fit a lot more virtual machines on the storage, overcommit the storage. It's not a performance issue as such. It's a performance factor because you're going to get a lot more VMs on your LUN, and they're all going to be doing I/O. But thin provisioning isn't itself a performance issue. But be aware, if all those VMs suddenly start running a service pack or a major update, or you push out some new application, whatever, they start grabbing disk space. Even for temporary files, they're going to start using that allocation you gave them, and on the back end, you could actually fill the data store. Again, be proactive before that happens. Know how overcommitted you are. Know that you're staying within your policies and your standards for that. So some specific metrics. Compute, CPU. CPU usage, 90%, that's not rocket science. If your host's running at 100%, you definitely have a problem. But CPU ready and CPU co-stop, they're more interesting metrics. Your CPU usage can be relatively low, but if you've, for example, handed out too many virtual CPUs for the number of cores in your host, the scheduler will be struggling, and CPU ready tells you that the virtual machines are waiting for CPU, they're ready to run, the scheduler doesn't have time for them just yet. And that knocks on into poor performance in the application and the end user calling the help desk. Co-stop is a related metric to ready. That's more for VMs with multiple cores. And the scheduler is telling you that it's really having trouble scheduling these multiple cores for a VM. Like I said, if you throw more cores at a VM, you can actually hurt the performance because the scheduler is struggling to keep up with that. And again, whatever tool you choose, make sure you can monitor at the host and the VM level and grab host metrics and drill down into the VMs that are running on that host. It's essential to have that map, those relationships. Memory, again, give yourself a little bit of breathing room. Don't run it at 100%. Remember, again, if you're overcommitting memory, be aware of that, because that's going to be a factor if VMs actually start to grab memory for some workload spike. Memory ballooning, part of VMware tools. It's another kind of everyday management tool that vSphere uses. It inflates a balloon, hence the name. It inflates a high priority process, grabs some memory inside the VM, forces the VM to drop some pages it hasn't touched recently. The VM, the Windows OS, for example, inside there, uses its own memory management, paging, basically. And then the host is able to grab that memory back and give it to another VM. You probably don't want to balloon more than 50%, and again, watch it at the host and the VM level, because if you're ballooning, if the vSphere host is moving half of the memory, 50%, especially in a sustained fashion, then it's doing a lot of shuffling. It's not going to be efficient, and it could definitely roll on into high disk I/O inside your VM, causing a slowdown in the storage backend because of all the paging that's going on. And again, tricky to track that down if you're not aware of how these metrics impact each other. And memory swapping, absolute no-no, last resort for the host. There are some new methodologies in the later versions of vSphere to compress memory within memory on the fly and use SSD caching and so on. If your host actually starts sending pages to disk because it doesn't have the memory to give to the VMs that are demanding it, performance will absolutely nosedive. We converted that metric. It's a native metric. We turned it into a swap rate metric in RMP. And you definitely, if you have sustained swapping to disk, that's a red alert. And again, track at the host and the VM level. Whatever you do, you should be able to drill down and see which of the VMs that are grabbing all the memory, which are doing ballooning, which are forcing swapping. You have that granularity. Storage. As Ray said, storage is where we find a lot of bottlenecks, configuration problems, performance problems. The back-end storage, virtualization leans on that very heavily. Storage space, you definitely have to watch that. Remember the disk pressure metric, be proactive about how you're overcommitting storage. The absolute minimum is 100 megabytes free in a VMware data store before your VMs will just become corrupted. I strongly suggest you don't monitor it to 101 megabytes before you raise a ticket on that. Again, it's up to you how much space you want to leave, factor in the disk pressure, but it is a very big problem if you fill up your data store. The VMs will just die, and you better hope you have a backup. Also track garbage or unknown files. They might be legit. There are some data stores where you put a bunch of ISO images, for example. vCenter is not aware of those. We have implemented some monitors and some data store scanning mechanisms in RMP that will tell you of unknown files. vCenter is using this data store. It knows what it put there. And if there's anything extra, those are unknown files to vCenter. And they might be ISOs. They might be orphaned VMs, orphaned snapshots. It's important to track that stuff and know what's on your storage. That storage ain't cheap. And watch snapshots too. Again, it's a policy thing. If you allow snapshots in your environment, most of our production customers don't. But choose a tool that definitely lets you be aware of that. If VMs have snapshots and they shouldn't, flag that up, because again, those are just going to grow. They're going to take up storage space. They eventually impact performance. And if they get really huge, sometimes you just can't commit them, or it takes hours. It's basically downtime. Latency. We did a lot on latency in our version 6 MP, actually. Broke it out to kernel latency within the host itself, within the hypervisor, to device latency on the storage backend. Within the host, kernel latency should really be 0. Those commands should just be flying out of there. You've got a configuration problem, or some kind of issue on the host side if kernel latency is anything above a couple of milliseconds. On the back end, less than 20 milliseconds would be nice. You can still actually run VMs. It depends on the workload. You go a bit higher than that. That's kind of the best practice number. And again, if you're lucky enough to have a SAN full of SSDs, you probably expect a bit less than that. But monitor for 20, 25 if you want to be proactive about how your storage is performing. And again, the relationship of which VMs are running on which data stores, which hosts are using which data stores, ability to see the hotspots and drill down and find out which VMs are forcing the high I/O, that's critical. I wanted to mention events, because we do talk a lot about performance. Performance metrics are what we often react to, and they're definitely critical. But if you're choosing a monitoring tool, events is the other side of the coin, and there's a wealth. RMP tracks several hundred events from Virtual Center, and they talk about the availability and the configuration and the status of everything. The virtual machines, the hosts, the storage they're using, networking, availability, hardware as well. So make sure you don't forget the whole events piece. It's a very important piece, and mapping events, configuration problems, to the performance counters that you're also gathering is a great way to help you troubleshoot. Now with that, I would like to take just a couple of minutes to show you how we implemented those ideas in the management pack for VMware. First, maps. So this is System Center, Operations Manager, 2012 SP1. And this is the first map we could talk about. The compute topology. So that shows your virtual center, your data center, your clusters, hosts and resource pools. You drill into a single host. I'll pull that back, and all the hardware components are here. We get the hardware data agentlessly as well, actually over the network. An agentless solution for VMware using the available APIs is definitely what you want. The host HBAs, the host physical network cards, all those components that, like I say, would be invisible if you just used an agent inside the VM. You can't see the physical NICs in the host, the HBAs in the host. And under each host, the VMs that are running there. And again, because we're agentless and getting all this data from Virtual Center, you can support any kind of virtual machine. These guys could be appliances. They could be running DOS, Windows NT. We don't care. We'll expose them as a virtual machine object in SCOM and track their metrics and their status. But if there is an agent inside the VM, like I said, most of our customers do deploy one inside their Windows VMs. We're able to actually attach that agent to the virtual machine. We hook that agent onto our topology. And then you have the benefits of like that end-to-end picture. So whatever that agent is monitoring, whatever Microsoft MPs, your own MPs, any third party, is now going to be integrated, if you like, into your picture of the VMware environment. This one's actually a virtual center. It's got SQL in there. There are the databases. So that's what I mean by the map and the end-to-end view. You can go all the way in one view from the data center to the database. briefly show you the storage topology too. This is new in our version 6. Again, knowing which virtual machines are using which storage, that's virtual center, data center, and now the data store is the LUNs, or the data store clusters, and the virtual machines that are running there. And to have that joined up picture, if you've got performance issues in all of those VMs and there's also a red light on the data store at the back end, well then you're halfway towards solving the problem, once you know what the problem is. Now, those topology views are great, but I think a lot of us who use Operations Manager kind of live in the alerts view. Alerts are what you have to solve. Alerts are the metric that the service desk is maybe measured on. Alerts raise tickets and so on. So we have some very detailed alerting capabilities, and more important, sort of the knowledge base that attaches to that. That's key. Whatever product you choose, you have to elevate your network operations guys. The frontline guys are not experts in everything. They're not going to be experts in VMware. You can't pay a VMware expert to sit there 24/7 in case there's an alert. So whatever tool you choose, make sure it has a knowledge base. It's going to help those guys with triage, guide them to root cause, help them to call the right guy at 2 a.m. That's very important. And of course, valuable alerts, best practice thresholds. Using that map, we leverage the map, the relationships that we have, to pull together different metrics. This data store has high latency. That's one metric, that's one monitor. You can get an alert on that. But we actually pull in the read and write latency for the highest hosts, the load in IOPS. We rank the top 5 hosts that are reporting latency to that data store. And again, dashboarding. We implemented a lot of those Ops Manager 2012 dashboard widgets. Ray showed a couple. Every one of our monitors has a matching dashboard, in fact. And again, it leverages that map. So you've got an alert, you hit the matching dashboard, you can drill into the objects that are using that resource, like the virtual machines on a data store, or the virtual machines running on that host. That's running a little slow. Yeah.
Your management pack makes mine look uncool, man.
Yeah, but yours only took you 10 minutes. Let me actually show you a dashboard on this one.
That's a good point.
Yeah, yours is free. Well, there's that monitor for unknown files. Again, that's a critical metric to track. Dashboards, you can see them at the booth. There's lots of dashboards. There's over 25 dashboards on, and the contextual stuff is really what's powerful, like I say. I knew someone would ask that. The question was, will we ever write a management pack for Hyper-V? And I guess my question is, would you all buy it? Well, then watch this space. Top 10 dashboards. Ray showed them as well in his MP. And again, these are leveraging the new widgets in Ops Manager 2012. But that's a very useful view for your ops guys. They can come check that every shift change and just see who are the top data stores, the top VMs, the top hosts in your environment. Use an in-context report. There's the one with the highest latency. Let's try a dashboard again one more time. Finally. So you drill into this dashboard and you see the read and write latency broken down for the data store. The alerts pane, again, context is so powerful, it's very useful. You can see the alerts for that data store and all the virtual machines just within that data store and all the applications, assuming there's Ops Manager agents integrated, the applications and the other metrics that you're getting from the virtualized OS in one pane. And that's a great way for you. You've got the data you need to correlate issues to understand what's impacted. And the lower chart shows the latency as reported by, again, the VMs in the context of that data store, just the VMs that run there. And you can sort that by the maximum, drill in, open the next dashboard that drills you into the VM and so on. Now, I did talk about being proactive. So I think I'm running over time a little bit. But forecasting, modeling, predicting, absolutely critical, because one of the great things, the curse and the blessing of the virtualized environment, is it's now so easy to deploy virtual machines. What used to take weeks of planning and talking to the guy who does the power in the server room and racking things and plugging them in, well, that's a couple of clicks, and you've got a new server. So you need to forecast and plan and manage and control that environment. You need to use predictive tools. One of the big features of our MP version 6 were the capacity planning ports that we implemented. This is the forecast for data stores. I've run this already and exported it to Excel. So you can see that we capture the actual metric, that's the blue line. And you can run this report over as much history as you have. We create a best and worst case trend, that's like the yellow bar, and we forecast that to the future. We do it for storage, we do it for compute metrics as well, for clusters. Take that trending, predict it to the future, and tell you in 60 days, in 90 days, you're going to be constrained for CPU, for memory, for latency on the back end, by pushing that metric to the future. Modeling is important as well. Can your cluster actually sustain the loss of one host, two hosts? How many hosts can you lose? You might have all kinds of HA, cool high availability stuff configured, but by taking the underlying metrics and understanding what's really running, what's the load, then we can tell you that you actually are safe to lose one host, to take one down for maintenance, whatever you need to do. And I think I had one report here. That's one of my favorites. That's where we take, I'll show you the parameters. You can put your cluster and your data store up there, and then you can add existing VMs. Like I say, you've got a project for 2 new Exchange servers next month, for whatever reason. You can use your existing Exchange VM with 200 users, whatever it is, as a model. You drop it in this report. You can tweak the thresholds, or you can just run it as is, and it's going to tell you for your whatever clusters and storage you ran it against, how many more of those virtual machines can you fit? And what's your constraining resource on fitting those VMs? Because you really don't want to just deploy 2 Exchange VMs and hope that you're not going to run out of something important. So we're tracking the memory that it's going to use. We're tracking the storage I/O, the CPU. We're tracking how many virtual CPUs per host core, as already mentioned. You might have all kinds of other resources, but if you exceed that resource, the performance of everything will drop, and you might wonder why. So that was a really quick run through. Again, I would say, encourage you guys to drop by our booth if you want to see a more detailed demo of that. Booth 1001, it's big, it's green, you can't miss it. Version 6 is out now, supports all those platforms, and the last point, you can have all that goodness for 10 free sockets. We are running that promo right now. 10 sockets, full product, 1 year support and maintenance. It's not an eval, it's not a demo. It's the full product for 10 sockets for you to put in your environment and kick the tires. And obviously, we hope you'll buy a lot more.
So it's free.
It's absolutely free and without cost.
Man.
And with that, back to Ray. Thank you, guys.
Thanks, Alex. Thanks for some cool stuff. So, kind of just wanted to end our presentation by giving a quick overview. That's the Twin Towers from where I came from. I come from, not I came from. I'm still alive. So, I wanted to use this analogy because the Twin Towers kind of represent virtualization monitoring in terms of Hyper-V and VMware as a whole, right? So imagine one tower is Hyper-V and the other tower is VMware. We can't just monitor one tower. We've got to monitor both towers. And do we monitor just the foundation of the building? Not really, because we got to take care of the floors. We got to take care of the people that's renting the office space and so on, right? So in terms of monitoring end-to-end an entire stack, that's really important. So not just performance of virtualization. So some of the things that Alex showed about being able to monitor SQL databases on a Windows Server virtual machine in a VMware environment with the virtualization platform. So that information is really useful, right? So any monitoring tool that you find today, not even System Center, I would encourage you to make sure that that end-to-end story is available. Right? So like even this one over here, very quickly, this is a distributed application diagram, topology diagram that we use to kind of look at the Hyper-V host and the VMware host at the same time. So looking at both environments, a little bit of what Alex showed earlier. And also from an application perspective, this is a useful diagram looking at it. We have an application and it's running Apache Tomcat. It's actually running on an Ubuntu Linux machine, and it's actually hosted on VMware. So having this end-to-end story, you can actually tell when someone calls you up and say the application is having some issues, let's see what's wrong immediately through a root cause analysis of this diagram. So kind of just painting that picture is quite important. So I have 2 minutes more. I just want to very quickly point out, I kind of figured that this was a little cool. I'm not trying to sell you this stuff. I'm not from Survision. But from a Hyper-V capacity management standpoint, I'm not sure whether you know, I think they have a booth here as well. They show some Hyper-V capacity stuff. So Alex showed you some cool stuff on VMware capacity. These guys have some cool stuff on Hyper-V capacity management, right? So you can see things like on my virtual machine, on my host, from an assessment level, I'm running about 7.3 to a single host. My memory is going to be depleted in about 3 to 6 months. My storage, I'm okay. I still have about 3 years left. And basically, that's some computation that they've done based on available and the trends that I've been using. From an optimization perspective, what I've studied from this chart is it actually shows the relevant host, what's the bottleneck like, what's the memory average per host, so you can actually see it from an overall perspective. Storage as well. I'm going to run out of storage in 1 to 7 days on one of the hosts, so I can actually look at that host, right? And from a provisioning standpoint, it helps you to look at, if I were to provision a new virtual machine, which are the hosts that I can look at, and so on, right? So I just wanted to just show that, thinking that it might be useful. Somebody will buy that?
Yeah, yes.
Cool. Okay. So kind of the critical points I wanted to share is I hope those metrics actually showed you some of the key stuff that we should be looking at, not only from a Hyper-V perspective, but also from a VMware perspective, and choosing the right central monitoring tool to show you both and to show you an end-to-end picture. Right? There is a session on building custom management packs done by Mickey Gousset. So that's on Thursday. If you guys want to take a look at how to build a nicer management pack than what I showed you guys. So I encourage you to go to Mickey's session there. So those are the general related resources. Before you leave today, help us to complete an evaluation form. Make it honest, please. If you fill in a good score, Alec will give you a prize at the booth.
Oh, yeah, sure, okay.
Yeah. He will give you 10 free sockets. for his VMware MP.
Yes. Bingo.
Okay, so I think we just ran out of time. Maybe you want to take one question, Alec? One or two questions? Does anybody have a question? I don't want to go without a question.
We explained everything. Wow.
No? Okay, if you guys have any questions, me and Alec will be around for in a couple of minutes. So thank you very much.
Thank you.
Enjoy your day.